Hello and welcome to the Sealing Systems Solutions webinar. My name is Jennifer Burton, Regional Sales Manager for Industrial Seals within the North of England. And joining me today is my colleague Alan Brown, Application Engineering Team Leader for UK Industrial Seals. I start with sharing the Skf Seal's global presence. Highlighted in green are the countries where we operate with Skf Seal's moulding, machining facilities, engineering, sales and customer service units. Countries highlighted blue, we operate with engineering, sales and customer service units. And most of the countries highlighted in white, we are represented through authorised distributors. And so the history of the Skf Seal business commenced in the year of 1974 in Italy with the startup of RFT, followed by a number of acquired seal companies from 1990, such as Chicago Rawhide, Goetze, Seal Pool, Macrotech Polyseal and Economont, all of which known today as Skf Sealing Solutions, operating as Skf Industrial Seals and Skf Automotive Seals. And so when we consider applications, it's important to understand the reasons for premature bearing failure, as reliable sealing solutions are essential for bearing system performance. Industry figures tell us that 50% of bearing failures are directly associated with sealing issues, of which impacts on cost and performance. So in this chart, for example purpose, we consider a gearbox application. On average, seals make up less than 3% of the cost of a new gearbox. However, seals are responsible for slightly more than 50% of warranty claims. And so a small increase in the cost associated with installing a premium seal can result in a significant reduction in warranty claims and associated losses. But of course, this type of cost versus performance comparison is equally applicable to other types of equipment. And now I'd like to invite my colleague, Alan.
So, the important thing to understand is, how do seals work? Well, we know that good quality oil seals do not just form a barrier, but they pump. This hydrodynamic feature is important because it improves the seal's overall performance and helps with the lubrication of the sealing lip. The approach angle on the oil side of the seal lip is steeper than on the air side. This creates a contact pressure curve biased towards the oil side, which can be seen by the yellow hatched area on the right-hand diagram. The surface structure of a seal looks smooth, but it isn't. It has microscopic surface textures referred to as asperities or microasperities. These are like the pores and the wrinkles on your skin. At rest, the asperities are uniform and undistorted, as is the surface texture on your skin. But if you pull the skin on the back of your hand, the skin texture gets distorted into a kind of chevron shape. The same thing happens to the surface of a seal when the shaft starts to rotate. The chevron type distortion is slightly biased towards the oil side of the sealing lip. This distortion creates a hydrodynamic pumping mechanism that encourages the adjacent fluid molecule to flow back towards the oil side. The next thing to consider is the primary sealing function of the seal. So if we look at the diagram on the far left-hand side, we can see a seal installed in a conventional manner, housed to retain oil or lubricant within a bearing housing. If we insert the seal the opposite way round, as in the next diagram, the seal is being used to exclude contamination. So this is its primary sealing function. In the next diagram, we can see two seals mounted in a back-to-back configuration. In this arrangement, we have one seal whose primary function is to retain the oil, and the other seal's primary function is to exclude contamination or to separate a different media. In the diagram on the far right-hand side, we have a pressure seal. In this case, the Skf CRW5 design, which is rated up to 3.5 bar pressure. On this diagram, you will also notice the seal has a secondary or auxiliary lip. This lip is a low friction dust lip designed to prevent light contamination from entering the system. So this is a secondary lip. We'll begin by looking at the standard range of SKF catalogue radial shaft seals. Typically, these seals range in size from 6mm shafts up to approximately 300mm diameter. You have two basic types available. We have rubberized outside diameter, which you can see on the top right-hand side of the screen, and the all metal outside diameter, which are the seals below them. These are typically used in gearboxes, motors, fans, pumps, drive systems, construction equipment, and many other applications. Okay. So the first seals we'll look at are our metric rubber OD shaft seals. Skf decided to develop a design standard for rubber covered shaft seals which would outperform our leading competitors' equivalent profiles. The result of this development is the standard designs you see here, which we refer to as MROD or metric rubber OD seals. Currently only available in metric, but we are in the process of developing an inch range for these seals. We believe these seals can be considered best in class. In this range, we have two standard material seal profiles. We have the HMS5, which is a single lip seal, and we have the HMS-A10, which includes the auxiliary dust lip. These seals are for non-pressurized applications up to a maximum pressure of 0.5 bar and speeds up to 14 meters per second as a general guide. We have two standard materials available, NBR or nitrile rubber, which will either be black or grey in colour, and this material is good for temperatures up to 100 degrees C. However, we need to allow for localised temperature increases at the sealing lip due to friction. So if the environmental temperature is, say, at 100 degrees, the seal lip temperature will be slightly higher, so we might need to go for a higher temperature material. The second standard material we offer is our Fkm material, which is brown in colour. And this material is good for temperatures up to 200 degrees C and also has very good chemical resistance. So if we look at some of the key features of these seal profiles, firstly, the outside diameter is beaded. So when the seals are press fitted into the housing, it isn't uncommon to get a reaction known as springback, where the elastic nature of the material causes the rubber to spring back out of the housing once it's been inserted. The beading outside diameter reduces the likelihood of this occurrence. Secondly, the seal has a moulded in metal reinforcement. This ensures good self-retention in the housing, and because it's rubberized, it also has very good corrosion resistance. We then look at the flex section of the seal. This provides the optimum radial load on the shaft. If the flex section is too thin, then the seal will not be so effective maintaining shaft contact, particularly at higher speeds, which potentially could allow oil to bypass the seal. However, if the seal flex section is too thick, we will end up with too high a contact force, which can create excess friction and heat, and potentially lead to material damage, excess wear of the seal, and shaft scoring. The sealing lip on these designs is spring-loaded to ensure good shaft tracking, particularly at higher speeds, or to compensate for shaft misalignment and lip wear. The sealing lip is what we refer to as knife trimmed, which ensures a very precise, high-quality sealing edge. HMS-10 profile also has the auxiliary dust lip. This is a low friction design, so to ensure that friction is kept at a minimum along with heat generation. Seals also have a robust seal retainer, so that's the wall at the front of the spring which keeps the spring in place. The graph you're looking at here are the results of an independent study conducted by Stuttgart University comparing pump rates of various seals. As you can see, the SKF M-Rod seal made of MBR pumped at over 3 times the rate of the world's premium brands, identified here as MBR3 and MBR4, and dwarfed the results of the budget brands tested, identified as MBR1 and MBR2. In addition to the difference in pump rates, our seals generally have lower radial lip load, which results in lower torque and lower power consumption. Okay. The next set of seals in the range are our metal OD seals, which have a proven track record for providing robust and reliable sealing and utilise the Skf Wavelet Seal geometry. These designs are available in thousands of sizes and styles, mainly in the inch range, but we also have an extensive metric range. Within this range, there are 4 standard seal profiles. We have the CRW1, which is a single lip seal design, the CRWA1, which includes the auxiliary dust lip, and then we have the CRWH1 and the CRWHA1, which have an additional outer casing. This casing improves the stiffness of the seal, which provides greater retention within the housing, so it's a more robust design. As a general guide, these seals can tolerate speeds up to 18 meters per second and 0.7 bar pressure. Okay. As with the HMS seals we've just looked at, there are 2 standard materials available. These are MBR or nitrile, temperatures up to 100 degrees C, and Fkm or higher temperatures up to 200 degrees C for improved chemical resistance. We can also provide these seals with stainless steel casings if required, but there would be a minimum order quantity to do this. So, the key features of these seals range are, firstly, you have the metal outside diameter, which gives good robust installation and secure retention within the housing. In the case of the CRH and CRHA seals, there is also the metal inner case, as I mentioned before, for high radial stiffness, so even better retention. All the seals are supplied as standard with the Skf watertight coating. This is a water-based acrylic sealant which accommodates for small imperfection in the housing board. The sealing lip is spring-loaded and also benefits from the Skf molded in Skf Wavelet Geometry, which has the industry leading pump rates. Again, these seals have the auxiliary or dust slip, which is a low friction design, so reduced heat and reduced frictional torque. In addition to these seal designs, because of the metal casing, an Skf V-ring can be run against the back face, which provides for a very robust method of excluding contaminations. Okay. So in this slide, we're looking at the Skf Wavelet Geometry. This is a hydrodynamic feature developed by Skf to optimize sealing performance. Unlike conventional seal lips, which are straight, the Skf Wavelet has a sinusoidal wave pattern. So as the shaft rotates against the wavelet, the contact point moves back and forth across the shaft, creating a hydrodynamic pumping action that pushes the oil back into the system. The combination of the wavelet and the material properties produce a pump rate that is higher than any other standard shaft seal on the market. A conventional seal concentrates all the friction forces and heat onto one thin wear path on the shaft, which produces a higher lip temperature and also leads to faster groove wearing into the shaft. The wave seal distributes friction heat across a much wider area, which reduces the underlip temperature, typically by around 6 degrees, and also reduces shaft wear. In this slide, we can see some benchmark test results from pumping performance that were conducted in the USA. You can see that both MBR and FKF wave seals outperform their competitor seals, and in one case, the competitor seal had almost no pumping ability. Even seals that pump poorly can still form a barrier between the oil and the atmosphere. So why is pumping ability so important? Well, it's because in the field, seals with high pump rates are able to mitigate other system flaws, such as substandard shaft finishes or misalignments. Seals with high pump rates are more reliable, typically last longer. In addition to the range, we have our CRW5 and CRWA5 profiles, which have the same wave lip seal technology, but for applications where there may be some pressure present, up to 3.5 bar maximum. However, if the pressure is greater than 0.7 bar, we recommend using a retaining ring or a shoulder on the low pressure side of the seal to stop the pressure from pushing the seal out of the housing. We now move on to what we class as the SKF industrial heavy industry shaft seals. These are for larger applications, which are typically harsh environments. So places you might find these seals being heavy gearboxes, hot and cold rolling mills within the metals industry, paper mills, renewable energy, crushers, mining and tunnel boring machinery, or marine applications. For our heavy industrial shaft seals, we have a flexible manufacturing process, which means no restriction to catalogue sizes. The seals are all made to order, and there are no tool charges, even for customer sizes, and no minimum order quantities. There are 3 basic styles available. We have the HSS, which is an all rubber moulded seal. We have, which you can see in the middle, the all black seal. We have the HDS seal, which is metal case moulded rubber seals. So the two profiles you can see on the left-hand side of the screen. And we also have the HRS seal, which is a machined polyurethane seal for difficult operating conditions, which benefits from high abrasion resistance and high tolerance of large shaft misalignment. This seal was originally developed for the wind energy sector. Seals are available in several material options, such as MBR for good general purpose applications, XMBR, which has improved abrasion resistance, HMBR, which has improved chemical temperature resistance, or for temperatures up to 200 degrees C, we have the Fkm Material. The HDS seals can also be supplied with stainless steel casings on request. So if we first look at the HDS, so the metal clad heavy industry seals, there are three standard variants. We have the HDS1, which is the standard profile, which has an Skf spring lock groove, which covers 270 degrees of the spring, which ensures very secure spring retention. We then have the HDS2 profile, which is exactly the same as the HDS1, but this design benefits from the Skf spring cover. This is a polymer resin that bonds the spring to the seal and is ideal for blind or difficult installation where there's a high risk of the spring being dislodged during installation. Thirdly, we have the Hds7 seal. So this is a springless grease seal, but due to its geometry and its excellent scraping effect, is also a very good excluder seal. Typically, these seals can tolerate speeds up to 25 meters per second and pressures up to 1 bar, and temperature resistance will depend on which materials are selected. So in additional to the standard profiles you just looked at, we have a large extended range of seal options. We have additional excluder lip variants available, which can either be in an elastomer material, a PTFE, or polyurethane. And these are for improved environmental protection. If the additional lip is on the front side of the seal, so in front of the primary lip, this is to provide the primary sealing lip with protection. Or if they're on the back side, this would be the conventional arrangement for excluding contamination. We can also seals with spacer-like options. This is to provide space between seals for periodical greasing, or to allow for grease purging between the seals. And normally in this kind of arrangement, seals are separated by a spacer or lantern ring, resulting in an additional component, cost, and complexity. Thirdly, we have unitized solutions for simplified installation and handling. The seals can either be mounted back to back to separate media, two different media, or for robust environmental protection, or in the same direction, provide additional sealing or sealing redundancy. So a belt and braces arrangement, if you like. And all are available on similar lead times to the core range. Okay, we now move on to the all rubber heavy industry seals. So unlike metal case seals, which are simply pressed into the housing and self-retain, all rubber seals must be actually clamped and retained in the housing with a cover plate to prevent the seal from walking out the housing and to ensure that it does not rotate with the shaft. This is demonstrated by the diagram on the left-hand side of the screen. The HSS profile benefits from several key features. The seal body is made from hard-grade rubber for improved seal stability and rigidity. However, the seal lip is still from the standard hardness material for optimum sealing performance. These seals also benefit from the Skf spring lock groove, which, as mentioned before, covers 270 degrees of the spring and provides very secure spring retention. And again, these designs can also be supplied with the Skf spring cover, which bonds the spring into the seal. Difficult installation and handling. In addition to this, we have our HRS polyurethane seal, which was developed to meet the demands of wind turbine main shafts, but can be adapted to many other applications where tough abrasive conditions exist or where there is potential for large misalignment. All seal options are available as solid seals or new equipment installation, or can be supplied in a split format for on-site installation where it's not practical to completely disassemble the machinery. And again, there's no restriction on catalogue sizes because these seals are all made to order, and we can accommodate any size, and there are no minimum order requirements. The extended range of these seals includes designs that include an auxiliary lip, contamination exclusion, as you can see on the left-hand side of the screen, or can be supplied with lubrication grooves on the back face of the seal, or back-to-back arrangements, as you can see in the diagram on the right-hand side of the screen, so that grease can be pumped between the seals to ensure the seals are well lubricated, or as an additional barrier between two different media. Okay. So that's our main range of industrial shaft seals. What we're now looking at is the Skf range of E-Rings. The primary purpose of E-Rings is to provide contamination exclusion when running against an axial face. The E-Rings can simply be stretch fitted onto the shaft, or can be more securely retained with locating collars, or in some cases, a clamping band. Since the V-ring spins with the shaft, any contamination that contacts the seal is thrown off the lip due to the centrifugal force, effectively removing contamination from the critical sealing area. E-rings can also be used to contain lubricants if mounted internally and the lip facing away from the bearings. As you can see in the diagram on the top right hand side of the screen, and it's the middle diagram of the three. When mounted in the conventional manner to exclude, the seal can also act as a grease valve or purge mechanism to allow grease to escape from the housing. So, for instance, if this housing is regularly flushed with fresh grease to ensure any contaminated grease is pushed out the system. V-rings can also run against the back faces of metal cased shaft seals to provide very robust contamination exclusion. In addition to the core range of moulded V-rings, we can supply machine seal solutions to meet specific application environments or where a very robust seal is required. So this brings us along to our Skf machine seal concept range of seals. These seals are machined from tubes on a CNC lathe. This This facility allows us to produce infinite seal sizes ranging from 3mm up to 4,000 millimeters as a single piece endless seal. However, we can go up to 14 meters or bigger in our using our polyurethane materials, using our special welding techniques. The large number of standard profiles allows us to meet specific application needs or fill in gaps from the catalogue range. Machine seals can be produced from a wide variety of material options, such as rubbers, polyurethanes, PTFEs, and various other polymers, to meet specific demands of an application. For instance, chemical resistance, food compliance, or oil and gas certification. This process is available for small batches, prototype seals, up to high volume seal production. In addition to the standard machine seal range, we can offer custom designs tailored to meet specific needs of an application. The manufacturing process allows rapid prototyping with no tooling costs, so multiple design modifications are possible to optimize the solution without the need for costly mold tool modifications or even replacement mold tools. In many cases, the finalized design is transferable to a molded product if volume is sufficient. This gives us endless possibilities in design and material selection. We have many standard materials and also an extensive range of special materials to meet certain industry certification requirements. For example, food and bev certified materials or oil and gas certified materials. We also have a standard range of machine seals to suit plumber block housings, or what we refer to as SSNL housings. These are split bearing housings, but very common within the industry. The housings have a single seal groove on either side, which can accommodate several bearing protection options, such as felt rings, labyrinths, or moulded contacting polymer seals. In addition to these options, we are able to offer machine seal replacements for the contacting polymer seals, either to fill gaps in availability from the catalogue range or to give greater flexibility in material selections. The standard material for these seals is our Ecopur polyurethane material, which is a robust material with excellent abrasion resistance. But the seals can also be produced in other material compounds if required to meet specific environmental requirements, such as high temperature, chemical resistance, etc. Again, these seals are available with no minimum order quantities. So we've looked at the main core range of our rotary shaft seals in this presentation, but there are many other additional profiles not covered in today's presentation that can be found in our industrial shaft seals catalogue, such as grease seals, PTFE seals, cassette seals, track seals, and metal face seals. And as mentioned, all those seals can be found in our industrial seals shaft catalogue, as you can see here on the left-hand side. And all the information you might require about machine seals can be found in our machine seal catalogue. So any information about any of the seals shown here today can be found in these catalogues. As you can see, going on through June and July, we have several other webinars available, which you might like to log into. as you can see here, and we're running those through till early July. Thank you for your time, and now be happy to take any questions you might have.